Guys, so we're going to model the difference between the severe rainstorms in Galetown. So we've been investigating how wind can affect an air parcel, how an air parcel cools, and now we're going to use the modeling tool, effective wind, to show how wind caused different amounts of rain during two different storms. All right, so our goal is to show how wind caused different amounts of rains in Galetown. We've got a bunch of do's there, things that we need to do. We need to label our model, show the amount of wind, show the amount and direction of the energy transfer, show the parcel temperature, show the amount of liquid water after the parcel has stopped rising, and show the amount of condensation and rain after the parcel has stopped rising. And then we've got some different modeling tool keys here. All right, so let's look and see what this model is going to look like. All right, guys. So on the screen, we've got our modeling tool here. All right. So the first thing that we are actually going to do is we are going to model, sorry about that, we are going to model Storm 3. So what I want to do is I want to add Storm 3, because that's the first thing I want to do. All right. And so the next thing that I'm going to do is I'm going to show the amount of wind in the before panel. So I know you can't see on your screen, but in the before panel, which is over here. Oops. In the before panel, we want to show the wind, and not on your screen, sorry. We have a wind strength of light. So what I'm going to do is I'm just going to use the smaller arrows, and I'm going to outline those. Okay, and then the next thing that I'm supposed to do is show the amount and the direction of energy transfer using our arrows. So we had high amount of water vapor, and we had a parcel temperature of very high. So if it was very high, I would assume that there was a lot of energy. So because there was a lot of energy, I'm going to add 3 arrows to show that, the energy transfer. And so the next part that I want to do is I want to show the parcel temperature after the parcel has stopped rising. So this is kind of a confusing piece here. So we have 3 parcels. I've got parcel 1, 2, and 3. Or we could do it the other way of 1, 2, 3. But which parcel did it come from? And remember that Storm 3 was after the lake, and it was a severe amount of rain, but it wasn't very severe. So I'm actually going to be working with this air parcel right here. All right. And so what I want to do is I want to show the parcel temperature after the parcel has stopped rising, the amount of liquid water, and then the amount of condensation. So the amount of water for this one was high, and then my temperature was very low. Then I want to add what my cloud size was and how much rain fell. Okay, and so that's what Storm 3 would look like. And I know I tried this earlier, so I'm going to take a screenshot and see what happens. Okay, and we're going to put done. We're going to save it to my photos and hope that that happens. All right, and then I'm going to go ahead and I'm going to actually erase everything here. And we're going to look at how that differs from Storm 4. Okay, so we're going to go with the pencil, and here we've got Storm number 4. Okay, and when Storm 4, first thing that we're going to do is we're going to talk about our wind. So in Storm 4, we had a whole lot stronger wind. So I actually want to use my big arrows here. Now, what was the energy transfer from my surrounding air, from the energy, from the air parcel to the surrounding air. So I used 3 arrows there, and you're thinking to yourself, Miss Trujillo, why did you use 3 arrows in Storm 3 and Storm 4? Because in our data, we know that it was very high. So the temperature before the storm was very high for both of them. Remember that the difference in Storm 3 from 4 was the amount of wind. So now what we're going to do is we're going to figure out which of the parcels we're going to actually draw out. Remember that the higher a parcel goes up, the more that air parcel cools, and the more rain and the more severe. So we actually want to use our 3rd air parcel here to talk about what the liquid water was and what the temperature was. So here, the amount of liquid water was very high, right? Because that parcel kept moving up and up and up. And then in order for it to do that, we had to have extremely low. And so what do our clouds look like? We're going to outline this biggest one, and we're going to show all of the rain falling there. All right, I'm going to take a picture of that, screenshot that. Let's look at it. Done. Let's save it to my photos, and let's pause for a minute so I can get both of these for you guys to see. Okay, guys, so technical difficulties, and unfortunately, I did not get screenshots the way I had wanted, and that is quite all right. It is what it is. So what I did is I did some color scheme here to kind of show the difference between Storm 3. Storm 3 stuff is all blue. Storm 4 is all in red. Notice, of course, that the energy transfer in both Storm 3 and 4 was the same. The main difference was going to be right here in our wind, right? And because there was a difference in the wind, so because there was a difference in the wind, there was a difference in storm severity, right? So that wind was able to push that air parcel higher, and as a result, that water vapor was able to condense a whole lot more. As it condenses more, it puts more rain in. All right, guys, let's move on to our next activity.